Hi guys, this is Mrs. Lyons. Today we're going to talk about a special part of stoichiometry that we do. It's called determining the limiting reactant, or sometimes you'll hear it called the limiting reagent. The limiting reactant is the thing in a chemical reaction that runs out first. Okay, now I want to use just a practical example that will help us wrap our heads around what it means to be a limiting reactant. So let's say that we are, instead of doing chemistry and using chemicals, we are making sandwiches. Okay, and we're going to make ham sandwiches. Okay, and in each ham sandwich I have a certain number of ingredients, and all of my ham sandwiches are going to be the same. Each ham sandwich has 2 slices of bread, it has 1 slice of cheese, and 3 slices of ham. Okay, so that is my recipe for a ham sandwich. Okay, now let's say I'm going to have a party. I'm going to have a bunch of people over for a picnic, and I need to make ham sandwiches for everyone. So I go to my cabinet and in my refrigerator, and I look, and I see that I have 24 slices of bread. I have 15 slices of cheese. And I have 20 slices of ham. The question is, how many sandwiches can I make? Now, I think this is a pretty easy question for most of us to figure out. If you think about it, what you're going to do is you're going to figure out, okay, I've got 24 slices of bread. Each sandwich takes 2 slices. That means from my bread, I could make 12 sandwiches. I have 15 slices of cheese. Each sandwich takes 1 slice. So that means out of my cheese, I could make 15 sandwiches. And I have 20 slices of ham. Each sandwich takes 3 slices of ham. So that means that I can make 6 sandwiches out of my ham. And I would have, 2 slices of ham left over. So the question is, how many sandwiches could I make? To answer that, I could only make 6 sandwiches. The reason that I could only make 6 sandwiches is, once I run out of ham, I can't make any more complete sandwiches. So I run out of ham. That makes ham my limiting ingredient, or limiting reactant. Okay. It also means that I have excess, I have leftover cheese, and I have excess bread. After I've made all the sandwiches that I could still make 9 more sandwiches with my cheese. I could still make 6 more sandwiches with my bread. Now we're going to use this example, this idea of what ingredient runs out first, to do some stoichiometry problems. Okay, so in the next example, I say, if 45 grams of hydrogen reacts with 45 grams of oxygen to produce water, which element is the limiting reactant and which is the excess reactant? And then I ask how much water would be produced. So what we're going to do is we're going to use our mole map, and we're going to do a question just like we've done in our stoichiometry problems. We're going to do grams to grams, but we're going to be looking, instead of just having one starting point, we're going to start from 2 points. Now notice there's no chemical equation for this, so we need to write a chemical equation. We have hydrogen and oxygen, so we need to write an equation. We've got H2, because it's a Hobrofinkel element, remember it's a diatomic element, and we've got oxygen, and they're going to react together to produce water. We should probably balance this while we're at it, because we always need a balanced chemical equation. Now we're going to set up our truth table. Okay, but notice something. I always tell you, just look for the number. Look for the number, ignore everything else. Well, in this case, we have 2 numbers that we have to deal with. We have 45 grams of hydrogen and we have 45 grams of oxygen. That means we're going to have 2 problems. Okay, so I'm going to set up 2 truth tables. All right, one of them I'm going to start with 45 grams of hydrogen. One of them I'm going to start with 45 grams of oxygen. Now, in both cases, my unknown is water. I want to know how much water is being produced. So I'm going to go from grams, okay, grams to grams. All right, so it's going to be a 3-step problem here. And I'm going from grams of hydrogen, and I'm going to get to grams of water. So let's think about our mole map here real quick. We've got grams of A to moles of A to moles of B to grams of B. All right, so look at our mole map. Grams of A here, next step, moles of A. So that's going to be moles of H2. Next is moles of B. That's what we're producing, so moles of water. And finally, grams of B. So grams of water. All right. Now we just bring everything down diagonally. So we've got grams of H2, moles of H2, and moles of H2O. This should be something that you are good at by now because we've done so many stoichiometry problems. Okay, this is just a 3-step stoichiometry problem like we've been doing. Okay, now when we have moles and grams, we know it's 1 mole over the molar mass in water. So, molar mass of hydrogen. Hydrogen is 1.01. We've got 2 of them, so we're going to have 2.02. All right. When we have moles of one thing to moles of another, we use the mole ratio, the coefficients from the balanced chemical equations. So 2 water, 2 hydrogen. All right. And then finally here we have moles of water and grams of water. It's going to be 1 mole of water. I need the molar mass of water. So I'm going to add up all of my elements, and I'm going to find out that it is 18.02 grams. Then I'm going to calculate. Let's see. I have 45 times 2 times 18.02 divided by 2.02 divided by 2. That's going to give me 401.44, and that's grams of water. Okay. Now I have to do the second problem with oxygen. I'm starting with 45 grams of oxygen. Again, a 3-step gram to gram problem. So let's see, I've got grams of A, oxygen. Now I need moles of oxygen. Then my mole map, I go to moles of B, moles of what I'm looking for, which again is water. And then finally grams of B, so grams of water. Now I bring my units down. Grams of oxygen, moles of oxygen, moles of water. All right. When I have moles and grams, it's 1 mole equals the molar mass. So 1 mole equals 32 grams of oxygen. When it's moles and moles, I look at the mole ratio. Water, stoichiometry, or coefficient for water is 2. Coefficient for oxygen is 1. So there's my mole ratio for water to oxygen. And then finally, last step, 1 mole is equal to the molar mass of water. We already calculated that at 18.02 grams. Now it's down to calculating again. 45, multiply across the top, times 2 times 18.02 divided by 32 equals 50.68 grams of water. Now, do you see what we did here? We calculated 2 different masses of water. And essentially what we're doing is if we said, in this case, if we start with hydrogen and there's plenty of everything else, that it doesn't stop the reaction, we would get 401.44 grams of water. If we started with 44 grams of oxygen, we would get 50.68 grams of water. So what this is saying is, since this is the smaller amount, the oxygen runs out first. Okay, if we start with these amounts, once we produce 50.68 grams of water, our reaction is going to stop because we're going to be out of oxygen. There's going to be no more oxygen to keep our reaction going. So what that tells us is that the oxygen is the limiting reactant. Okay, because less water is produced with oxygen. So oxygen is the limiting reactant. That means that hydrogen is the excess reactant. And as for the amount of water produced, that would be the 50.68 grams. That would be how much water is produced before the reaction comes to a stop. So when you do a limiting reaction problem, the key is you're just setting up 2 gram-to-gram problems. You're comparing the final amount of the product formed. The lesser product formed tells you what the limiting reactant is. The other reactant is the excess. I hope this helps. We will practice this. We're actually going to do a lab on this in class. I will see you there.